Hello, welcome to another class again. Today we are going to be talking about balancing of chemical equation. When we talk about balancing of chemical equation, it's according to the law of conservation of masses or conservation of matter, which states that the total mass of the reactant must be equal to the total mass of the product. Therefore, energy is conserved. So there is no loss of masses. The total mass of the reactant of a chemical equation or chemical reaction must be equal to the total mass of the product formed from that reaction. That's the law of conservation of matter. So as a result, whatever number of elements you have here must be equal to the number of elements you have here also. So take note of that. That's one of the law. So when you look at this equation as we have on the board, we have sodium reacting with tetrahydrols of a 6 acid to give you sodium tetrahydrols of a 6 and hydrogen. Now from this equation, the number of sodium here is 1, the number of sodium here is 2. So it's not balanced. And how do we now balance the process? Now in balancing chemical equation, we have to use according to the Dalton's law of the Dalton's atomic model that states that when a element or compound they combine in simple ratio. So which means we cannot start with bigger numbers. We must start already use this one. So we have to look at 2, 3, or 4, 5 or 6, depending on what number we can use to balance it. So look at everything here. Just take a look at this equation again. Draw closer and view this thing clearly. You will see that what we have here is 1 sodium, 2 sodium. So if we have 2 sodium here, definitely we need a second sodium. So let's put 2 here. Now if we put 2 here, we have automatically balanced this equation without any stress, which is clear. It has been balanced. Because if you look at it, you have 2 sodium, 1 sulfur, 1 sulfur, 2 hydrogen, 2 hydrogen, 4 oxygen, and 4 oxygen. So everything is balanced. Let's take another equation, something like this. And this will give us Na2SO4 plus H2O. This is an acid and base reaction. Now, if you look at this particular equation also, in this case now, there are 2 sodium here. There is 1 sodium here, 2 sodium here. How do we balance this equation? So we have to look at it. There is only 2 sodium, but you only have 1. So take note, the number is placed behind the element, not in front of the element. Take when you are balancing, you must place it behind the element or the compound. So in this case, you have 2 here. Let's put 2 here. Now putting 2 here, let's calculate the number of hydrogen now. Hydrogen here is 2 plus 2 because these 2 affect everything here. So it becomes 2 sodium, 2 oxygen, 2 hydrogen. So we have 2 hydrogen. Total hydrogen in the reactant area is 4. Let's look at total hydrogen in the product area now. We have 2. So it is clear that the hydrogen is not balanced because over here, the total hydrogen here is 4. So what do we need to do? Let's add 2 here. Now adding these 2 here makes this hydrogen here 4 because this you multiply 2 times 2 gives 4. So that means we have 4 hydrogen which balances with this one. But let's now look at the oxygen. The oxygen balance, sulfur is balanced. There's 1 sulfur here, 1 sulfur, same thing, 1. Oxygen is balanced here. Here is 4 oxygen. Here is 6. So we have 4 plus 2, which is equal to 6. Let's come and find how many oxygen do we have here. Here is 4. And these 2 also affect this oxygen too. So we have 2. That's equal to 6. So we have 6 at the product, at the reactant and product area. Then sodium, as we have done, we have 2 sodium here. And we have 2 sodium here also. So this equation is balanced. So we are going to do one last one and then I'll give you some to do. Now let's take let's take this. Look at this process. This is called the thermal decomposition reaction, which gives you this CO3 plus CO2 plus H2O. Now this particular reaction is called thermal decomposition because it involves heat. Okay, heating rather. Now in this process, this is reaction. What do we have? 1 sodium, 2 sodium. So let's balance the sodium. In balancing the sodium, we need to introduce a 2 behind this. Now introducing a 2 behind this compound, which is this particular one that was decomposed by heat, we have 2 sodium, we have 2 hydrogen, we have 2 carbon, then we have 2 times 3 oxygen, which is equal to 6 oxygen. Because these two will also multiply these 3 to give us 6. But at the reactant area, we have 2 sodium,